Assalamualaikum and hi everyone. Topic 10, Application of Differentiation, Lecture 1 of 3, Part 3 of 4. At the end of the lesson, students should be able to A. Find the point of inflection, B. Sketch the graph of a polynomial function up to degree 4. Okay, now we will continue with the definition concave upward and concave downward. Take a look at the graph below. For the first graph, that is this one, we will see that from point A to point B, the function f(x) is increasing. And what about the concavity? The graph is concave upward. Okay, we will see that from point A to point B, the graph is increasing and the concavity is upward. What about the second graph? For the second graph, this one, the function is increasing also, but the graph concave downward. Okay, why downward? You see that this is the shape of the graph because the graph bend down like this. What about the third one? For the third one and the fourth one, the function f(x) is decreasing. Okay, this one is decreasing also, and the last one also decreasing. What about the concavity? For the third one, the graph is concave upward. You see, from point A to point B, the graph is decreasing and it concave upward because the graph bend up like that. For the last one, the graph is decreasing and concave down. Okay, concave downward. And the graph is decreasing. Downward, why? Because the shape of the graph bend down like that. Okay. Okay. Thank you. Relation between the sine of d squared y dx squared and concavity. What is the relation between d squared y dx squared and concavity? Let f be a differentiable function on the interval from A to B. A. If f double prime is 0 for all x on the interval from A to B, then the graph of f is concave upward on the interval from A to B. Okay, so if f double prime is positive or more than 0 for all x on the interval from A to B, then the graph of f is concave upward. Okay, on the interval from A to B. Okay, B. If f double prime is less than 0, f double prime is less than 0 for any value of x on the interval from A to B, then the conclusion is the graph of f is concave downward for the interval from A to B. Point of inflection. Number 1. A point P on the curve y equals to fx is called the point of inflection if f is continuous at the point P, and the second one, the curve change from concave upward to concave downward, or change from concave downward to concave upward at the point P. Number 2, the point of inflection for the function f is any value of x in the domain of f at which d squared y dx squared or f double prime equals to 0, or f double prime is not defined. Okay, so the first definition is dy dx or f double prime equals to 0, or the second one, second definition is f double prime is not defined. When dy dx, d squared y dx squared or f double prime equals to 0 or f double prime is not defined, so we will get the point of inflection. Take a look at the graph below. For the first graph, we will see that fx is increasing. Okay? For the interval before p, for the interval less than p, we will see that fx is concave downward. For the interval greater than p, fx is concave upward. So that is the changes of sign for concavity here, from concave downward to concave upward. So P is called the point of inflection. For the second graph, we will see that the function fx is decreasing, but the concavity for the interval before the point Q is concave upward, and for the interval greater than P, the graph fx is concave downward. So the concavity is changed from concave upward to concave downward. Therefore, the point P here, the point Q here is called an inflection point. So the conclusion is both point P and Q are called the inflection point. Okay? We continue with the next example. A curve is given by the function fx equals to 2x to the power of 4 minus 4x cubed plus 1. Describe the concavity of the graph and find if exists the point of inflection. Okay, we start by differentiate what is the function fx. Y equals to fx equals to 2x to the power of 4 minus 4x cubed plus 1. F prime x is equals to 8x cubed minus 12x squared. We need to find second derivative. F double prime equals to 24x squared minus 24x. To find inflection point, you need to equals to 0 f double prime. Therefore, 24x squared minus 24x equals to 0. 24x factorized, and inside the bracket is x minus 1 equals to 0. And we get x equals to 0 and x equals to 1. Okay. So now we draw a table. For the first row of the table, the interval is negative infinity to 0, continue with 0 to 1, and the last is 1 to infinity. So this is the line x equal to 0 and line equals to x equals to 1. For the second row, this is the test value of x. Okay, the test value. You can pick any value between negative infinity to 0, let's say negative 1. Between 0 and 1, let's say negative 1 over 2, and this one 2. These three value you substitute into f double prime. F double prime. Okay, we want to find out what is the sign of f double prime. Sign of double prime, substitute negative 1 into f double prime, you will get positive.
24 times -1 times negative, so the answer is positive. Substitute 1/2 into f double prime, you will get negative, and substitute 2, you will get positive. So what is the conclusion for fx? When f double prime is positive, means fx concave upward. When f double prime change to negative, fx concave downward. And this one concave upward. Okay, so the conclusion is the function is concave upward in the interval from -infinity to 0, -infinity to 0, and another one 1 to infinity. Okay, and concave downward in the interval 0 to 1. Because of the sign for f double prime change from positive to negative and change to positive, so this it means that there exists the point of inflection at x equals to 1 and x equals to 0. So you have to find out when x equals to 0, what is the value for y? Y equals to 1. When x equals to 1, the y equals to -1. Substitute into fx. Therefore, the point of inflection are 0, 1,